All right, what we're going to do today is just look at some really common shapes and common problems that you see with a lot of similar triangles. So the first one is the bow tie, which, we looked at these first two yesterday, so if you want the actual full proofs, check out yesterday's video. But the bow tie is when these two lines are parallel, and that's crucial because without the parallel lines, we're not sure if they're similar or not. So with these parallel, what it means is we know that the alternate interior angles, like angle T and angle R, and angle S and angle P, have to be congruent to each other. So right there, right off the bat, that's angle, and these two triangles are similar. But also, we know that the vertical angles are congruent too. So we could prove all three of those angles really quickly and easily. And there we go. Those two have to be similar. Anytime you have a bow tie looking shape like this, and you have parallel lines, then it means that these two triangles are similar by angle. All right, with the A-frame, and I say that because it looks like an A-frame house. Looks like that with the little line right there. Again, the crucial component here is this line has to be parallel to this line right here. And as long as these two lines are parallel, then this little triangle, DIE, is similar to this big triangle, DVO. And it's kind of like weird to look at, because you have to, these two triangles kind of overlap each other, which will become crucial shortly. But yeah, it's true. So with that, we said yesterday that these two angles have to be congruent because of corresponding angles being congruent when the lines are parallel. Likewise, these two angles are congruent because corresponding angles are congruent when the lines are parallel. And finally, this last one, angle D is congruent to itself because angle D right here is part of the little triangle and it's part of the big triangle. So by the reflexive property, this angle has to be congruent to itself. Now, this one down here, I call it gross because, well, it is kind of gross. And actually separating these triangles out from this diagram right here, this is the way you'll see it. And if there is a Regents this year, which again, highly doubtful, but if there is, then you're going to see a lot of these diagrams. Now, the reason that it's okay is that there's some rules, and we'll teach you rules on how to solve problems like this. But you can also solve it with similar triangles too. Now, let's compare this triangle and this triangle. First off, all three of these have a right angle. So check right off the bat, nailed it, good. Now, if we look at this one and this one, you see how they both share angle A? Angle A has got to be the same here and here. And that's just the reflexive property again. So angle A on this one's congruent to angle A on this one. And once again, these three gray triangles are just a breakout of this whole diagram here. This whole triangle's down here, the left triangle's over here, and the right triangle's over here. Nothing crazy. Now, so first off, these are similar because angle, angle. Perfect. Now let's look at this one. If we look at this triangle on the right, this triangle on the right has angle C right here and right here. So let's label that. I'll label that in blue. I'm going to use two arcs. You'll see why in a second. Okay, cool. So what we know now is that this triangle and this triangle have to be similar by angle, angle. So this is similar to this. This is similar to this. Is this similar to this? Huh. Well, here's the thing. Take a look at this down here. If we look at these, this is 90 degrees, which means these two angles have to add up to 90 to make the whole thing 180. So, if this is the same as this, then this would have to be the same as this, because these three angles have to add up to 180, and we already know two of them are the same. So that means the third one has to be the same. So we can actually label that this is the same too. Now, by the same exact logic here, we have the blue angle and the 90-degree angle. This one has to be the same as the red angle, because again, they have to add up to 180. So, if you look at it, all three of these triangles are similar to each other with the exact same angles. But again, don't freak out miserably because there's some rules to figure out how to get some side lengths when you're given a diagram like this. Rules all based off of these three triangles, of course.